Welcome to the final video in section 4.4, and I do apologize for those two previous ones. I made it just slightly too long, so I had to cut it, and I had to cut it at a really strange spot, but realize it's all there, and you can get the entire video without the glitch right there at the cutoff. And this one should be well under 15 minutes, so it shouldn't be a problem. Okay, we left off with example number 13. We need to determine, without graphing, whether the given quadratic function has a maximum value or a minimum value. Then we need to find it. And so this is stuff that we've already used in the previous two examples, 11 and 12. And we are given this. So the first thing we need to do is determine or realize that since this opens upward, we're going to have a minimum. We do know that much. We know that right off the bat. And then we are asked, what is that minimum value? Well, here we actually do need to find the k value, but in order to do that, we need to find the h. So h will be negative b over 2a, which is equal to 3 over 2, or 3 halves. To find k, it's going to be f of 3 halves, which is equal to 3 halves squared minus 3 times 3 halves minus 8, which equals 9/4 minus 9 halves minus 8, which, when it's all said and done, equals negative 41/4. And so, what is the minimum value? Negative 41/4. That's the smallest value that we can get. Example number 14. Same directions, different problem. F of x equals negative 2x squared minus 6x. Since this is negative, that means we are closing, or it's opening downward, which means we have a maximum. And then in particular, we try and find h. H is negative b over 2a, which is 6 over negative 4, or negative 3 halves. To find k, the value we're really interested in, we have to find f of negative 3. So that will be negative 2 times negative 3 halves squared minus 6 times negative 3 halves. So this is negative 2 times 9/4 plus 9. This is negative 9 halves plus 9, which equals 9 halves. And as I said before, that is the maximum value of 9 halves. The final examples are word problems, so we're going to need to look at what does it say and what do we need in order to solve these particular problems. So we start out with 15. We have profit, and the profit function, according to the problem, is negative 0.002x squared plus 1.2x minus 300. And we need to find the number of pretzels that need to be sold in order to maximize it. Now, how do we know it's a maximum? Well, this negative means it opens downward, which means we have a maximum. And when we are asking how many pretzels are required to be sold, we are actually asking what's the x value, or what's the h. So that's all we actually have to calculate. So h will equal, like any others, it's negative b 1.2 over 2a, negative 0.002. Well, this becomes negative 1.2 over negative 0.004 and this ends up equaling 300. 300 what? Well, we need to sell 300 pretzels to get the maximum profit. And number 16, consider the quadratic model. H of t equals negative 16t squared plus 40t plus 50. For the height in feet, which is represented with h, of an object t seconds after it's been projected straight up into the air. So t represents time in seconds. Find the maximum height attained by the object. Okay, so the maximum height, we know it's maximum because this negative here means we get a maximum value, not a minimum value. So the first thing we have to do is to find that maximum height. Well, here we're actually interested in the y values, but in order to get the y value, we need to find our h and our k. So it's negative b over 2a, which is negative 40 over negative 32, which equals 5/4. And so to find k, what that maximum height would be, it's h of 5/4, which is negative 16 times 5/4 squared plus 40 times 5/4 plus 50, which equals, let's see, this ends up being negative 16 times 25/16 plus 50 plus 50. Okay, and negative 16 times 25/16 ends up being negative 25. So negative 25 plus 100 equals 75. And this would be the maximum. So we are really interested in we know that that is 75 feet up in the air. Then it asks, how much time does it take to fall back to the ground? Well, we know that 5/4, it starts at 0 and 5/4 of a second we're at the top. It's going to take just as long to get back. So 5/4 plus 5/4 or 5/4 times 2, either way you want to look at it, ends up being 5/2. 5/2 what? 5/2 seconds. Or in other words, 2.5 seconds from the time that it is thrown upward, it will hit the ground again.